tangent. Now we're going to learn what the tangent graph looks like. So first thing is write this down. Tangent of theta is equal to sine theta divided by cosine theta. Or in other words, it's the y value divided by the x value of all these coordinate points, which are really, really small because I didn't have enough room on the notes, so I made it small. So hopefully by now you're getting used to this unit circle. We take the y value divided by the x value at whatever angle we're looking at. So let's start off with the easy ones, like 0. When is tangent going to equal 0? It's when the top is a 0. So when is the y value 0? Here. So let's find the tangent of 0 degrees, or 0 radians. So that's going to be a 0. When else is the y value a 0? Way over here at pi. So it's also a 0 there. And then it comes back around in a full circle again, and then this is 0. So that one's where the tangent value is a 0. What about at the pi over 2 mark, the 90 degrees? The x is a 0. Well, if I have a 0 on bottom, that is undefined. So right here at pi over 2, we get an undefined situation. That represents a vertical asymptote. That's the big thing about this. When you have 0 on bottom, remember that? Vertical asymptotes. And where's the other part? Here. This is where x is a 0 way down here. So we get that this one is also undefined, which also represents a vertical asymptote. Okay, now on these, the pi over 4, if you look right here, it's the same thing. Square root of 2 divided by square root of 2, the y divided by the x. So that's just a 1. Over here, it's the same thing divided by each other, except that one of them is negative. So that one is negative 1. And then here we have 5 pi over 4. They're both negative, so this is a positive 1. And then 7 pi over 4, one of them's negative, so we're back to negative 1. Okay, let's take this. I'm going to do a quick little screen capture so you don't have to remember all of these things, and paste it here onto the page. That way we don't have to go back and forth looking at the other slide. All right, I'm going to leave this here, cover up a little bit of stuff as we're trying to sketch our very first graph. So first thing, let's identify when do we have an undefined graph, because that will tell us when we have zeros on bottom of that fraction sine over cosine. If you remember that, sine over cosine. So when we have undefined, that's because there's a vertical asymptote. So let's start off with that. So we have pi over 2 is undefined. So right here, let's put a dashed line. And then again at 3 pi over 2. So how often is our tangent graph repeating? Whenever we have a vertical asymptote, I'm having a hard time graphing that. Whenever we have a vertical asymptote, it is repeating itself. So it has at pi over 2, 3 pi over 2. The period lasts every pi over b. So this is important to have down on your notes. It is different for the period of tangent. If you remember, for sine and cosine, it was 2 pi over b. For tangent, it is different. Okay, that's a big hint here. One of the first things that people will get wrong on some master checks or tests is recognizing the period of tangent. So it's pi over whatever that b value is. So in this case, b is a 1, and therefore the period of this graph would be pi over 1. So it's just a pi instead of 2 pi. All right, let's keep going here. Let's sketch some other asymptotes. Let's go to this way. So if I continue the pattern, it would if I get to pi over 2, then I skip out a whole extra pi to get to negative 3 pi over 2, and there is my graph of tangent for the vertical asymptotes. All right, next, let's plot some points. So I've got 0, 0, and I have pi over 4 and 1, and then let's keep going here. I have undefined, so that's my vertical asymptote, 3 pi over 4 and negative 1, pi 0, 5 pi over 4, 1, and then you continue the pattern. So what is going on with this graph? I'll show you here. Let me finish getting these dots. This is what the tangent graph does. So I start here, and I sketch towards the vertical asymptotes, and this way down towards the vertical asymptotes. It almost looks like a cubic graph. It's very similar to a cubic, except that it has vertical asymptotes here. Cubic graphs don't have vertical asymptotes. So you can fill in the rest of this, and there's your tangent graph. All right, one other thing that we can grab from our equation, and that is that this value of a right there, that helps us get a coordinate point. That coordinate point will be from the middle here. If we move over halfway to the vertical asymptote, then that value is our y value. Let me say this again. Whatever this is here in front, we're used to thinking of it as amplitude. Halfway to the vertical asymptote, that is our value of A. Halfway to the vertical asymptote from the middle, that is our value of A. So that helps us sketch the graph a little bit more accurately. Okay, so if you don't have all that down, go ahead and get it copied down. Let's go on to our last example, number 4. So the first thing is, let's recognize what the period is. And in this case, it is going to occur every pi over b. In this case, that's 2. So that's how often the period is going to occur. And let's look at the phase shift. So if I take a 2 out of this, I'm dividing by 2 here. It becomes an x. Divide this by 2. And it just becomes pi over 2. So let me show you how to do that again. Divide by 2 and divide by 2. It's like I make a fraction. So now the 2's in front. This becomes x, and this becomes pi over 2. So that means it's shifting right. How far? It's shifting right pi over 2. All right, so now it used to be that a tangent would go through right here at the origin. Now it's going to be shifted right pi over 2. So now it's going to be there, and then it repeats every pi over 2. So then I jump out another pi over 2. Whoops, here's a pi over 2, another pi over 2, another pi over 2, and we can go backwards on our period. Pi over 2 left, pi over 2 left, and so forth. And that just continues the pattern. Halfway in between these periods then, right in the middle of this, is where we have our vertical asymptotes. You're going to have a whole bunch of vertical asymptotes here. I'm not going to draw every single one. I'll just draw a few of them. And keep going, keep going. Now, halfway to the vertical asymptote, do you remember our A? Our A here is a 1/2. So if A equals 1/2, what does that do for us? It tells us halfway to the vertical asymptote, we have a value of A right about there. And then that would also be down -1/2 that direction. So about halfway, halfway, and then you can sketch, oh, that's difficult to sketch that accurately. You can sketch the graph of that. So we're just looking, the quickest way for your teacher to grade this is when they can see that you have the correct vertical asymptotes, you have the correct middle points here right on the x-axis, and then to see that you have the value of A halfway between the point and the vertical asymptote. That's usually the easiest way for us to grade. And that pattern just continues and continues and continues. We won't draw this whole thing here, but you need to have at least several of these on your graphs. All right, you are done. You finished the lesson. Congratulations.